Hi everyone, my name is Evgeny and this is my first video that opens up the brewing series of videos where we're gonna talk about one of the oldest and the most widely consumed alcoholic drink, beer. And I know this is a very exciting topic for many of you, and we obviously can go like for hours talking about the beer from scientific point of view or from just an average consumer point of view. However, I'd like to limit my video time as much as I can and trying to use a little bit more scientific approach when I cover one or another topic. And obviously your comments, your feedback, your questions are more than welcome and much appreciated. And if you're interested in any particular topic, please let me know, and we can obviously cover it in my next one of my next videos. But today we're gonna talk about yeast and the basic principles of the yeast management at the brewery. So why yeast, and why did I pick up this topic first? Let's say logically, maybe I should go with brew house or raw material cover. However, I do believe that the yeast plays an extremely important role in the brewing process, and sometimes, unfortunately, they value and the role underestimated. So I just want to briefly go over the major and important things in terms of the yeast handling. This is a very broad topic. So, and we can can be. We can spend hours and film lots of videos about that, but I just want to go briefly over the bunch of important things. I want to start with a brief overview of the yeast morphology. So that the yeast is a one-cell live organism, and this is important, a live organism, because also yeast is considered one of the major four major ingredients that we use in beer making, right? But other three ingredients, malt, hops, and water, so not live. And everything we talk about the yeast, we should consider from that point of view, from that perspective, that is a live cell, and we should treat it accordingly. So there's a two broad group of organisms based on the cell structure: eukaryotic and prokaryotic. So the yeast classified to be a eukaryotic organism along with the plants, animals, because they cell more complex, more advanced, and it contains organelles, special organelles. And prokaryotic cells, when we talk about prokaryotic cells, we talk about bacteria, when the cell contains only genetic materials and nothing else. So again, I don't want to spend much time talking about the yeast structure, the yeast cell structure. So you can obviously find it in any biology textbook or internet. Just want to focus on a couple more interesting things. So the yeast cell contains a special storage. When it's stored, they call it reserved carbohydrates or sugars. And the yeast cell consume it in case when there's nothing else to be consumed in the environment. There's no more food in the environment, so the yeast cell starts eating its own and using its own carbohydrates to live, to survive, right? So we're gonna come back to this very interesting moment later when we talk about autolysis later in the video. So this is one thing, but also yeast cell can go two ways. For the living to live and to multiply and to get in energy by two different ways. So the first with the aerobic, with the presence of oxygen, and they call it respiration. And the second way is without oxygen presence, so anaerobic. And they call it fermentation. And this is obviously the major and the most important process of making beer. So the thing is that everybody knows the fermentation when the yeast consumes sugar and revert it to alcohol and CO2. But the yeast consumes sugar in a certain order, not randomly. So they start with the simplest sugars with the monosaccharide, glucose and fructose, and they switch over disaccharide, maltose, which is the main fermentation sugar, and then the trisaccharide in a certain order. Nitrogen is a very important element for the yeast as well, and the yeast cell uses nitrogen to form its own protein for the cell, right? So this when we talk about FAN or free amino nitrogen in the word we should keep in mind that there got to be a certain level of a certain content of free amino acid. And again, so I just want to repeat that. So the yeast is the only living organism that can switch from one mode to another mode, from aerobic mode to anaerobic, right? So what no one else can. So yeast can be classified in a bunch of different ways, depending on the certain characteristics or abilities. Let's say from number one, let's say from the fermentation behavior. So the top or bottom fermenting yeast, right? Top goes up to the surface, the bottom goes down, settle down, and there's a major difference between top and bottom, that the bottom yeast can completely consume trisaccharide raphenols, and the top fermenting yeast can only consume that trisaccharide, only like 1/3 of it, right? So that's a very interesting moment. So based on the fermentation behavior, based on the fermentation performance, so to what extent the yeast can ferment out the beer, to what limit of attenuation. Number 3, based on the flocculation ability, right? So how fast the yeast settle down, and this ability it depends on the genetics. It's very interesting. So flocculation ability. The other classification based on the sensory profile, the off flavor, byproducts profile that the yeast produced during the fermentation, and many other factors, right? There's also different yeast strains, right? Different yeast strains, which each of it has its unique characteristics and qualities. So let's say bottom, for example, bottom fermented yeast, we can relate Pilsner strain, we can relate lager export. Same for the top fermenting, it's a Weizen, the wheat they use for the wheat beer, Weizen yeast, that the Kolsch yeast, L yeast, etc. So it's a different type of different yeast strains. The form we can use the yeast at the brewery. They can be dry yeast, they can be liquid yeast, right? So always the pros and cons for both. Dry yeast, easy to use, doesn't require a special equipment. However, it's considered that they have lower viability compared to liquid yeast, and the product perception itself when you use the dry yeast. Liquid yeast, that's what we're going to talk about. That's where the yeast management applied to the liquid yeast, right? So using what do we gain by using a liquid yeast? Obviously, it's a money saving, right? So you don't have to buy yeast for every batch. This is also the yeast from generation to generation, but to a certain point, of course, and I'll tell you later why. So they only strengthen. They get stronger. They more adapted to the stressful environment, and therefore they perform better. So the fermentation is better. Flocculation performance is better. Other activities and other factors all better, because the yeast. I would say from generation 3 to generation 6, that's your best choice for healthiest and strongest yeast. This is the liquid yeast, and also a couple words literally about the maintaining different yeast strains at one facilities, right? So now it's becoming more and more popular when the people use different yeast strains, even like they introduce the wild yeast Brettanomyces at the same facility, which is obviously a certain risk, and it's a challenge to maintain this many yeast strains in one facility. But I would say you should adhere to the two basic principles. So one is maintain your cleaning procedure, and it's got to be very thorough, very diligent cleaning procedures, right? And number two, to keep and maintain your proper records, because you put one label on the wrong tank, you pitch the wrong yeast into the work, right? So, and that outcome is unpredictable if that's the case. So although both those procedures aimed only one thing, just to prevent those strains from cross-contamination, right? Because if it's cross-contaminated, so that will impact your beer profile, can be changed, etc. Other consequences. So yes, and now we're switching over the basic principles of the yeast management. So there's a couple things about that. Number one, this is the generation. So as I said before, you can use liquid yeast up to a certain number of generation, and they recommended go up to 10 max. You can go further. Nothing's gonna happen, right? Your yeast still gonna be performing. However, there's a certain when you go further over 10 generations, with each generation your micro contamination risk increases. Your quality of the yeast declining, and in overall performance you can expect some troubles with your fermentation performance, right? So because the yeast cell genetically unstable, and if any stressful factors can affect the yeast cells, and then can be modified or mutated, right? So sometimes you cannot even control those factors. You can only guess, right? You never know the truth, right? So so this is one thing in terms of the generations, and also the first generation is not a very good one, because the yeast is weak, they don't flocculate good, they stays a lot in suspension, and even it is recommended to use the beer with first yeast generation to blend during the filtration, because the filtration, that affects the filtration run, that affects the turbidity, etc. So it's not really good. So like I said, your best is from 3 to 6 generation. So generation, then the pitching. The pitching recommended ratio is 0.5 to 1.25 million cells per milliliter per Plato. That means if you're having worked 11 Platos, so that there should be around 11-12 million cells per milliliter. That's your ratio, right? So it depends on lager, it's a little bit more, higher, L less, but it's a basic reference, right? So it's important to do your cell count before pitching, so you know how much exactly is your need to pitch, right? To execute your fermentation. I know that not everybody has the proper equipment, people, time, etc. And there's also recommendation. There's a 1 liter of slurry yeast per hectoliter of beer. You know that it's gonna ferment. It's gonna do its work. So nothing's gonna happen. It's no criminal in it. However, the more quality control you put on over your process, the better result, and you should expect an expected result. So so this is the yeast pitching and the yeast count. Again, over pitching, under pitching, both negative things, right? So under pitching, your sluggish fermentation, abnormal fermentation, your a lot of off flavor, sulfur compounds increase the ratio increase. Diacetyl, the problem with diacetyl, over pitching, less harmful, I would say, but also you introduce more dead cells into the beer. There's a lower ester profile you should expect, and some other negative things. Storage. Yeast storage. Basic principles. Pitch yeast or repitched yeast as sap. Do not store for longer than 2 or 3 days, because there's no nutrient, there's no food during the storage for yeast, and they start eating its own components, and as a result, it's in the end you have autolyzed, you have dead cells, etc. So 2-3 days max, temperature 2.4, sorry, from 2 to 4 degrees, and also ideally you should cool the yeast before storage to bring it to that temperature, right? Because the yeast got a bad heat conductivity, and if it's sitting in a cone, even though you're cooling your cone, in the middle you still will have a warm spot and a warm temperature, right? Because it's a bad conductivity. So your cone cooling doesn't really help. So this is a storage. Again, storage can be with a tank with agitator or without, for better homogeneous mixing. Again, different manufacturers, different recommendations. It's up to you. Aeration only. If you want to aerate only before pitching, because you don't want to trigger and activate yeast metabolism and then do nothing. Obviously, ideally, when you before the yeast pitching, if you have the yeast pitching line, do obviously CAP and do steam. Sometimes like the steam, it's much better. If you have this option, obviously go for it. This is storage. So yeast equipment. Pick up a proper pump, because the shear forces when you transfer the yeast with the wrong pump, and it's not really gently handling the yeast, so the shear forces can harm yeast cell and can be damaged, and then negative consequences towards filtration, towards the process, etc. Right? So pick up a proper pump. Usually they recommend peristaltic pumps for that purpose. So this one thing, and the most important thing, the best time for yeast removing, for yeast harvesting, right? So when is the time? There's debates going on, right? But it's been confirmed and experimentally determined that the yeast starts flagellating right after they've done their job. So that means after fermentation is over, there's no more food, there's no more sugars. For yeast, they start flagellating, they start settling in the cone. And that's the time that you have to remove the yeast from the cone, right? Because what's happening, nothing but harm when the yeast is sitting in the cone, right? So this under a lot of stressful factors, as the temperature, as CO2, alcohol, osmotic pressure, hydraulic pressure, lack of nutrient, etc. It's all the harm. The yeast eventually start autolyzing. Autolyzing when the yeast cells breaks up, the membrane breaks up and releases all the andesite components from the yeast cell into your beer, which is fatty acid, nitrogen, sulfur compound, enzyme protease, which negatively affect the foam stability. So it's only negative effects in all possible ways that affects your colloidal stability, negatively your filtration, your sensory, your foam retention, as I mentioned before. So try to avoid autolyzed process, right? So remove the yeast earlier. One of the indicator of the autolysis, that can be pH. If you measure pH of the yeast, and if it's over or closer to 5, you see that indicates that the autolysis commenced already. So try to avoid that. Worm cropping or worm harvesting versus cold harvesting, which is better? I would say closer to the final gravity, or let's say a day after the final gravity, just remove the yeast, right? Whether you want to save it for repitching or you just dump it, but just remove that, right? So you can crash cool your tank later. You can do repeated crops. It's actually recommended, which is good. But do not wait when it's too late, right? So basic principles for the harvest is the first portion of this goes to the drain, because it's a troop, it's the dead yeast cells, hops residues, etc. So your best ideal health is yeast. It's the middle, it's the second layer. That's the yeast you save. And the third layer, it's the poor flagellating yeast or the thin yeast. You don't have to collect that as well. Just get rid of it. These basic principles. Very important microelement for the yeast growth is zinc. So you can use it as a zinc sulfate or zinc chloride, 0.5 to 1 gram per 10 hectoliters of wort. It's kind of recommended ratio. But it's up to the brewmaster and the brewery. So it has to be determined experimentally. If you're having a problem with your fermentation, then you can play with your zinc ratio. Control, basic yeast quality control includes, as I mentioned, yeast cell counts, pH, availability, which is like 95, not less than 95% of good cells and not more than 5% of dead cells. Vitality, some brewery they check it. It's a kind of indicator of the common general yeast health, but some do not. It again depends on the brewery, and obviously microcheck. And again, I didn't mention which yeast, when you make a decision to which yeast to reuse, repeat, or harvest. So you should look at it from a different perspective, right? So obviously microcontamination is no good, right? So the yeast from the bad, abnormal, or sluggish fermentation, no good for reuse, right? So the yeast from the batch that had abnormal or some kind of different off flavors, no good, right? So again, I understand that the real life is different and sometimes you have to find a compromise, but you need to, it's got to be your call which way you want to go, right? Sometimes you can go with a microcontaminated yeast if any parameters are good, right? So it's totally on the brewmaster decision. And the last thing I want to mention in this video and this topic, that the yeast washing. So there's a technique when you wash your yeast with a weak acid, let's say 10% phosphoric acid, to clean it. If in case the yeast contaminated, to reduce the bacterial load from the yeast, you use this, you use acid washing. Again, pros and cons, depends on the philosophy, but to me, I would rather go with a healthy, clean, not contaminated yeast if I have one. If I don't have, probably I would think about the acid washing, right? I have no choice. But again, don't forget that this is another stressful factor for the yeast cell, right? It's a life organism, and I even read somewhere, I read in an article, it says if I was a yeast cell, I would not enjoy the experience of the acid washing, right? And I totally agree with that, right? But if you still want to go with that, so you should keep in mind there's a certain factors, certain techniques you should adhere. So there's you should maintain your pH 2.1 plus minus 0.1, temperature 4 or 0 degrees, length time not more than 1 hour. Some recommend 2 or even 5 hours. Constantly gently agitating. So these techniques have to be implemented during your wash. But don't forget this also negative effect of it, because what's happening is demineralization is happening, and as well as washing out of nutrient from the yeast cell itself. So again, you should carefully, if you want to implement that procedure, you should carefully think about all the possible negative factors and make your own call. And if you do that, then track the yeast. How do they perform after the acid washing? How's your fermentation? How's your beer profile? How's sensory? And if it's all good, so go ahead with that, right? So it's nothing wrong. It's been implemented for a long time in the brewing industry. So this is kind of my brief overview of the yeast management. Again, this is a very broad topic, and I'll try to talk about yeast, and we'll be talking about yeast in the next videos. Yeast and diacetyl, yeast and colloidal stability, other interesting topics. But I hope I covered the basic principles of the yeast management at the brewery in this video. And if you have any questions, comments, you're more than welcome to leave them under this video, and subscribe my YouTube channel Brew Call, subscribe Instagram account. Your feedback much appreciated, and don't forget, thanks for watching this video. Don't forget to have your beer of the day, and I'll see you in the next